Hello students, today we will solve the exercise questions from the lesson electricity. In the previous video we have solved the question number up to 15 we have solved. So in this one video we will solve the exercise question from the question number 16. So the question number 16 is which uses more energy, 1250 watt TV in 1 hour or a 1200 watt toaster in 10 minutes. So here we have one 250 watt TV. So given data is what here? We have the power of TV set is 250 watt. TV set power is 250 watt and the time T is 1 hour. Okay, and we have one more appliance, that is toaster. We have one more appliance, that is toaster, which is having the power 1200 watt, which is having the power 1200 watt, and time they have given it is 10 minutes. Here we have to calculate the which uses more energy. It means in between these two electrical appliances which uses more energy, that is E is equal to question mark, right? We know that E is equal to P into T. E is equal to P into T. This is equal to P is how much? It is 1250 watt. T is how much? It is 1 hour, right? This is equal to 250 watt hour. So the energy consumed by the TV set is 250 watt hour. Similarly, come to the toaster. So we know that E is equal to P into T. This is equal to P is how much? It is 1200 watt, right? And time they have given in minutes. Now let's take into the hour. So it is 10 divided by 60 hours. This is equal to this 0, both are get cancels together. 6 ones are 6 twos are 12. So 200 watt hour. So 200 watt hour is the energy consumed by the toaster, whereas TV set energy consumed 250 watt hour. So what is the question here? Which uses more energy? So here TV set uses more energy than toaster. So here I need to write therefore TV set uses more energy than toaster. So hence we have solved the problem. Next question, question number 17. An electric heater of resistance 8 ohm draws 15 ampere from the service mains for 2 hours. Calculate rate at which heat is developed in the heater. So here we have a heater which is having the resistance 8 ohm. So the given data, we have a heater which is having the resistance 8 ohm, draws 15 ampere from the service mains, which means the current draws by the heater is 15 ampere, right? Now for how much time? That is, time is they have given 2 hours. Time they have given for 2 hours. Calculate a rate at which heat is developed in the heater. calculate the rate. Look at here, we have the word rate. Rate at which heat is developed. Rate, it is just equal to, it is nothing but the power, right? So here the heat developed in the heater which is equal to power. The heat developed in the heater is equal to the power, right? And we know that the power formula P is equal to I square into R. Okay, now this is equal to, what is I? It is 15 square. What is the resistance? It is 8 ohm, right? This is equal to 15 square. It is 225 into 8. This is equal to, multiply 225 into 8. It is 1800 joules per second, or you can write watt. So the heat developed in the heater is 1800 joules per second or 1800 watt. So hence we have solved the problem. Next question, question number 18. Explain the following. First one, why is the tungsten used almost exclusively for filament of electric lamps? This is the first question. Let I explain you. We have total 1, 2, 3, 4, 5 questions in question number 18. So just one by one I will explain this one. So first one, we have why the tungsten is used in the filament of electric bulb. So here we have to give the reason for that one, that tungsten metal, it is having the high resistance and it is having the high melting point. So as the tungsten is having high resistance and the high melting point, so when the current is passing through the tungsten metal, that it becomes hot and emits the light. So the reason that for using the tungsten metal in the filament of electric bulb is it is having high resistance and high melting point. Okay, right. Now second one, why are the conductors of electric heating devices such as bread toaster and electric irons made up of an alloy rather than pure metal? So here the question is, whatever the heating devices we have, those are made up of only alloy rather than the pure metal. So instead of pure metal, why we will use only alloys? So we have to give the reason. So here compared to the metals, okay, compared to the metals, the alloys are having high resistivity, right? Compared to the metal, the alloys are having high resistivity, and when the current is passing through the alloy, so here there is a large amount of heat is generated in the alloy, that is the conductor, that is the metal as made up of the alloy. Okay, so because of this one, the alloys are used as heating element compared to the pure metal. Now next one we have question number 3, that is why is the series arrangement not used for domestic circuits, or series arrangement are not used for domestic circuits? Give 3 reasons. So in domestic circuits, that is in our home, why we will not prefer series connection? Okay, we need to give the reason. So first reason that we can give, that why we will connect the domestic circuit in series, because why we will not connect in series? Okay, because the first reason is in series connection, whatever the current is passing through the appliances, it is same, that we don't want. So each appliance must pass the different current. So in series connection, what will happen? Every appliance will get same current, so that we don't want. So series connection we will not prefer. And second one reason is when the appliances are connected in series. Okay, when the appliances are connected in series, the total resistance, it becomes larger. So whenever the resistance will become larger, the current is going to reduce. So we will not prefer this series connection in domestic circuit. And one more reason we can give, that we cannot use the switch, on and off switch, separately for each circuit. Okay, we cannot use the different on and off switches for each circuit, so we will not prefer the series connection. So these are the three reasons we will give that we will not prefer the series connection in domestic circuit. And fourth one we have, how does the resistance of a wire vary with its area of cross section? The area of cross section and the resistance, how they are related to one another. So here the resistance of a conductor and the area of cross section, these two are inversely proportional to each other. As we know that when the factors depending on the resistance of a conductor, already we have studied that when the resistance and the area of cross section are inversely proportional to each other. It means the area of cross section increases, the resistance will decrease. Okay, or the resistance will decreases means the area of cross section decreases. So here there is a inversely proportional relationship between resistance and the area of cross section. And next we have finally, why are the copper and aluminum wires usually employed for electricity transmission? So for the electricity transmission, we will use copper and the aluminum. Okay, because the copper and the aluminum, these two metals are having low resistivity. So as they are having low resistivity, which means the current can easily transmit through these wires. So we will use these two wires for the transmission of electricity. And during the transmission of electricity, there is a very small amount of loss of electricity you can see, and that is in the form of heat. So here, so these are some of the reasons for the given questions. Okay, so hence here all the exercise questions from the lesson electricity, question number from 1 to 18 we have completed. Thank you.